Hello Internet, welcome to World of Zero. In this video we are going to be playing with a tool called Shadertoy. So this is a interactive website that works with, I'm hoping WebGL, but what it lets you do is write shaders and browse other people's shaders in real time. So this is just the default project. What we're going to be making today is sort of like a Hypno-Disc. So if you're familiar with like the cliched like hypno thing, the black and white spiral, that's what we're going to be making. And so all you have to do is just implement a shader function. It actually has quite a few features. So if you want, you can plug in like microphone input, webcam input, keyboard, some SoundCloud if you want to play music. There's other music options too. There's textures, videos, etc. We're not going to use any of that because I don't really know how, and let's start basic. What we're going to be working with is just trying to figure out how to draw that spiral. And so what we want is effectively an angle calculation from the center of that screen. So these UV coordinates are going to be from 0, 0 to 1, 1, I think. That may not be correct. One sec. There's an easy way to test this. Oh, whoa, that's not right. I tried to save. That's not going to do what I want. So if I restart this, we are going to get this. I'm going to take out... There we go. So this will be 0, 0 down here. And then you can see this is combining our green and red up top. So that's 1, 1. And that's 0, 0. So if you've used Java before, same as that, same space as that. I believe that's just OpenGL's standard from bottom left to top right. So anyway, what we need to do is put a point in the center, and then we just need to calculate the angle of every point from that point, and then we should be good, I think. So that's what we're going to start with. We are going to shift these UVs by, I think this works. So I have never written a shader in this before. So this is my first, I need to stop hitting save. That's going to keep happening. So we need to shift everything. So I'm shifting this down. So it's going to be off the screen to the left here. So if I start, that black kind of pops up. I feel like I went the wrong direction. That doesn't seem right. That doesn't seem right at all. Oh, yes it does. Sorry. So we would expect the black because this is all less than 1. So this will be 0.5 over here, 0.5 for the red component, which will be our x, 0.5 for our y, etc. So what I want to do now is I have a vector, which is from negative 0.5 to 0.5. We want to multiply that by 2. And now it's going to ask us for a float. From my experimenting, it seems fairly pedantic about what you do. Unity tends to be fairly lenient, but this is a little bit stricter. So this now gets us between -1, -1, and 1, 1 in the top right up here. So that effectively gets us a unit vector. I don't really think this is necessary because we're going to use an arctangent to get the angle, but I'm going to do that anyway because it just makes it easier to pretend like things are kind of in this unit space-ish. Yeah, kind of making things up, but that's fine. So, how do I want to do this? First off, we're going to want, there's two things that combine, or that make this up. The first is the distance from that center, which is going to be, well, we already actually have that, don't we? Because the length of this vector is our distance. So we can actually just say, let's see if this works. Float distance equals the length of our UV. And so this is going to pull out the length of that UV. It's going to calculate how long it is. I don't know if that's the proper function or not. And then we'll just stick that into our, that'll be our blue vector. Yeah, so it gets blue around the outside now. So we still have the red and the green, but now it's blue around the outside. So that kind of gives us a distance calculation, which we can then use later on. So the other thing we need is an angle. So this angle is actually going to define how this whole thing works. So the spiral is just going to be basic sine and cosine, I think. But the difference is we need a phase shift. Or we need to actually shift this based off of the radius. That was a bad explanation. But effectively at the point, we want to go around and have it end up here one length longer than it was at the start. So it will spin around and then it will end up so the inside edge of the new spiral, or so the inside edge of the line, the outer line, aligns with the outside edge of the inner line. And if that doesn't really make sense, hopefully I can illustrate it better. Effectively, you have a bunch of stacked lines that are moving out. And so we want this inside one, after it completes a revolution, it has to be at the outside one. So we need to kind of shift it out. Don't know how that's going to work, but we're going to make it up. So let's do an arctangent, and I believe this is y divided by x. Could be wrong here, but let's plug that in for our x, or for our red value. That looks somewhat like what I expected. Is it what I expected? I think so. Okay, this is getting a little bit funky. So 0, 0 would be this way, I believe. And then it will rotate around, become 1. Then it looks like it becomes negative. That doesn't seem right. Let's see if there's an ATAN 2. Nope. Okay. So we're back to our division. I don't know. This doesn't seem right to me, but we're gonna work with it. We're gonna see what happens. I had already deleted our time, so I'm gonna regret that as well because I'm gonna want that later. But what we want now is for our color. We'll just call it the color, I guess, to be equal to the sine of our angle. Will this work? We'll find out. Plus our distance. No, let's just stick with the angle for now. So we should see ripples coming out from the outside, and then we'll have to work in some additional shifts. And we'll also need a semicolon. Okay, so I have a color. Let's actually plug this in now. So I'm going to plug it in for all 3 values, so it should go to black and white now. That wasn't what I was expecting. What? Our angle. And then we plug that into the sine, so our angle comes in. And then we have a color. So I don't think this is right. That it doesn't seem right. How? I don't think this is an arctangent. One sec, I'm gonna go look this up because I think my math may have screwed up. I may not be remembering trig like I thought I remembered trig. Aha! I have discovered my issue. So, if you just do an arctangent, that only works for segments. I don't know what the actual term of it. Quadrants, right? Quadrants. Effectively, we've divided this into 4 quadrants. So we have 0 to 90, 90 to 180, 180 to 270, and then 270 to 360. Those are our 4 quadrants. And they're just, yeah. So what was happening is our arctangent, just doing it normally, will actually kind of not handle changing those quadrants great. So you can change the formula. That's what atan2 does. Turns out, WebGL uses just an atan with a comma between the 2 arguments instead of division, and then you get this. And this is what we would expect. So this is covering an entire sine wave. So if I do this and add a distance in here, we should see something interesting start to happen. So this is sort of what we're going for. It's, you can't tell, obviously, but it is what we're going for. And I can prove it to you by multiplying this by a bunch, by a float. Ta-da! So all we're doing here is taking our distance and actually creating ripples. So if I pull out this angle here, like so, we just get all of these concentric rings. But if I pull the angle back out, what happens is it actually offsets that and actually slowly moves it forward by the angle, which a sine wave repeats every rotation. And so this angle actually causes the entire thing to repeat over and over again. And so that's why this works. So if you want to flip it around, you should be able to just change the angle. Or not. May have spoke too soon. Nope, yep, that is happening. I just wasn't paying attention. So that all works. Then, I think, I don't remember what the time was. Let's see if I just create a, that's not going to work. Well, no, we're gonna find time. I don't know how to get time, but we're gonna find it. Oh, well, that's useful. They're right there. So let's pull out the global time, like so. And now it spins. Granted, it looks like it's kind of going out, but whatever. We can subtract this and it will go the other way. That's definitely going up, but you get the idea. So this 100 here is actually controlling how much this repeats. So if I drop this down to like 10.0, it gets bigger, and then I can kick it back up to like 50, which is kind of an intermediary, and you sort of get the idea. Let's see. I'm going to regret this, but let's see what happens. Can I pull in an input? Maybe. I'm wondering if there is a way to set up like an integer input. It doesn't look like it. Okay, we'll skip that for now. That's too bad. But this is super basic. There's nothing crazy going on here, but you get the idea. We have a spinning Hypno-Disc-y thing, but it's not like, it just looks like a sine wave with some black stuff. So actually, ooh, that could be cool. Let's do, so that's one of the colors. Let's do color 2. And let's actually plug in the same thing, but let's give it a cosine. I've hit save again. Shoot. So we'll give it a cosine here, and then we'll give it a sine, but we'll add, because we'll add half of a radian. So we'll move it all the way. Will that work? Let's actually not do that. Let's do all sines here. And let's do float 2 pi equals 3.14 159,265 something. I think there's probably a variable for that, but whatever. Well, that's close enough. Let's multiply that by 2.0. There we go. That can go away. And so this 2 pi is the total rotational angles between everything. Every quadrant, I guess, covers half a pi. So if I offset this by 2/3, so 2.0 divided by 3.0 times 2 pi, and the other one by 1/3 of pi, that means each of them are offset by 1/3. I should, making this up on the spot, but I should be able to plug in each of these for this, and we should, I'm saying should a lot, can't use 2 there, pi 2, sure, that'll work. So this should get us, yes, that is super awesome. So yeah, that's a thing. That's actually kind of weird, but cool. So I don't know, there's a bunch you can do with this. And the cool thing is that you can actually make this entire shader public. So other people can edit it. And there's a lot of other really cool things out on this site. Like really cool things like fully procedural raycast landscapes and physics engines and all of that, all done in shaders. So if you want to learn more about shaders, definitely check this tool out. I'll probably post a link to this in the video description. So if you guys want to check that out, go for it. If you make a change to it or do something completely different, I'd love to see it. So drop a link in the chat. It'll probably get hit by the spam filter just because it's got a link in it. But I can unblock those or whatever it takes. So yeah, this is Shadertoy. And this is a really weird example, but I thought it's simple enough, but it's also kind of got some of that trig stuff that makes it interesting. So I don't know, I thought it was cool. So yeah, there we go. We could actually, before I go, this resolution should have the viewport resolution in pixels. So what if we use half of this? So I was wrapping things up, but I'm getting back into it. Let's see here. Take this resolution, subtract half of it. So I resolution times half and subtract it. Do everything else. This is going to be really tiny. I think that's just because this is too high. I don't think that's actually what it looks like. It's just super small. Maybe. 0.01. I may have just screwed everything up. Oops, well, I guess we get to find out if it has undo or not. Okay. I guess I'll abort now. That was interesting. I don't exactly know what just happened, but a thing happened. So I was planning on just using the resolution because you could see with the old thing, it was actually getting skewed a little bit. So my hope was that it would actually not be, but that didn't appear to be the case. So just seeing if I missed anything to make that work, because that would be cool. So we're going to subtract that. I can probably take off that multiplication. That's not really needed. We've got our distance calculation, which just lengths our UV. We get our angle. Do a bunch of stuff. Really cool stuff. And then do really small multiplication. And we still just get that. Okay. Yeah, I don't know. Oh, okay. At least undo works. So let me bring this back. But yeah, anyway, there's a lot of cool stuff you guys can do. Maybe you can get that working or do something interesting. I don't know, surprise me. But this is where we're at. It's super simple. Obviously, I didn't try to go overboard here. Just kind of wanted to introduce the tool, and I think it's a really cool way to learn shaders, because you can kind of just take anything that anybody's made and kind of tweak something. And some of the really cool things aren't that many lines. Like this entire thing is 15 lines of code. There's ray traced editors, or like ray traced renderers and things, and those are only like 100 to 200 lines of code. So you guys can go and check those out. It's a great way to learn. I've said that way too many times. So I'm going to leave it here. If there's any feedback you guys have for me, anything you want me to change or do better, let me know. I'd love to hear it. If there's any other suggestions you guys have for other videos we could do, let me know in the comments and I'll see what I can do. But that's it for this video. So until next time, see you, Internet.